All right, let's look at homework 4.3, problem number 10. All right, so we have this f of x given, and for part A, we want to find the vertical asymptotes and the horizontal asymptotes. All right, for the vertical asymptote, it is clear that when x equals 0, it's going to blow up. So we know that you're going to have x equals 0 is going to be the vertical asymptote. All right, then for horizontal asymptote, so if you take the limit at infinity, you can see that the second term goes to 0, and third term also goes to 0. You're left with 1. So y equals 1 is going to be the horizontal asymptote. All right, so let's check the answer. All right, I came back and looks like we got the part A correctly. All right, let's move on to part B. Find the interval of increase and of decrease. All right, so let's do that. So for that, we have to find the derivative. All right, so let's take the derivative. F prime of x is equal to, all right, oh, actually, first, let's rewrite this. This is 1 plus 5 times x to the negative 1 power, and minus 8 times x to the negative 2 power, since x is on the bottom. Right, if you take the derivative, derivative 1 is 0. Derivative of that is put the negative sign in front, so it's a negative 5 x to the negative 2. Right? And then minus, actually, it's going to be, derivative of that would be negative 2 times negative 8 is positive 16 x to the negative 3. All right, so if you want to simplify this, let's see, let's write it. All right, so we have, so we can write it as a negative 5 over x squared and plus 16 over x cubed. Right? So we can find the common denominator, which will be x cubed. So I'm going to multiply top by x and the bottom by x, just the first term. So we're going to get, so denominator would be x cubed. So that's good. And then on top, you have a negative 5x plus 16. Right? So if you set that equal to 0, and you can see that basically set the numerator equal to 0, so x is going to be 16 over 5, so 16 over 5. All right, then we can just split this into, so we can do a number line. Maybe I can do a number line here. So we do a number line here. So here's the x-axis. So I have to put 2 tick marks, one for 0, and the other one for 16 over 5, right? Then we're going to look at the sign of f prime, right? So we can try any number less than 0, so x equals maybe negative 1, right? So if you plug in negative 1 here, so the denominator, so we're looking at this guy right here, right? So denominator is going to be negative 1 cubed, so it's going to be negative, right? Negative 5 times negative 1 positive plus positive. So it's going to be positive divided by negative. So it's going to be negative. All right, between 0 and the 16 over 5, we can try x equals 1. Right? So if you plug in 1, the denominator is now positive, and the numerator is going to be 16 minus 5 is still positive. So it's a positive over positive. So it's going to be positive here. All right, after 16 over 5, so it's 16 over 5 is 3 point something. So x equals, say, 4, right? If you plug in 4 there, the denominator is positive. Numerator is going to be 16 minus 20, so it's going to be negative. So we have a negative sign there. Right? So we know that its original function is going to be decreasing before 0, and then increasing between 0 and the 16 over 5, and after 16 over 5 it's decreasing. Right? So let's type it in. Right? So we know that it's increasing between 0. Right, we cannot include 0 because 0 is not in the domain. And 16 over 5. Right, then decreasing is from negative infinity to 0. And union, set union. And then we're going to start from 16 over 5 to positive infinity. All right, so we have that. All right, let's check the answer. All right, I came back and looks like we got the part B correctly. All right, so let's look at the part C. We want to find the local maximum value and the local minimum value. All right, so looking at this, we can see that we're going to have a local minimum at x equals 0. So this is going to be the local minimum there. And then here we are looking at the top of the mountain. So we have a local maximum there. So we need to find, let's see, f of 0. Actually, I'll have to take that back, right? This function is actually, there's a vertical asymptote there. So we do not have a local minimum there, right? But we do have a local maximum. So we need to compute f of 16 over 5, right? So what's this? You have 1 plus, right, 5 times reciprocal of x, so it's going to be 5 over 16 times 5, so it's a 25 over 16, right, minus, right, so 8 times, I have to do this, 8 times reciprocal of 16 over 5, so 5 over 16 squared. So that's what, 25 again, and then 16 times 16. Right, I'm going to write it that way for now. All right, so we have, let's see, so you have 8 and 16 cancel out, so it's going to be 2 there. All right, so we can find the common denominator. That will be 16 times 2, so it's going to be 32. Right, so 1 is going to be 32 over 32. Right, so 25 over 16, we multiply top and bottom by 2, so it's going to be plus 50 over 32, right, minus 25. So this is going to be 25 plus 32, so it's going to be 57 over 32. Right, so we're going to have 57 over 32. That's the maximum. Right, maximum value is 57 over 32. Right, and then minimum value does not exist. All right, let's check the answer. All right, I came back and looks like we got part C correctly. All right, so let's look at the part D. So we want to look at the concavity and the inflection point. All right, so let's do that. All right, so we're going to take another derivative. So f double prime of x is equal to, so derivative of that would be negative 2 times negative 5 is 10, x to the negative 3 power, right? And then negative 3 times 16 is negative, what's that? 48, negative 48, right? X to the negative 4 power, right? So if you simplify this, it's going to be 10 over x cubed minus 48 over x to the 4th power. All right, then take the common denominator. All right, so we can just multiply top by x and bottom by x. So we are getting x to the 4th power. And then we have 10x minus 48. So 48. All right, so if you set that equal to 0, you can see that x is going to be equal to, set the numerator equals to 0, so 48 over 10. 48 over 10, which is going to be divide by 2. I could actually divide by 2. So you're going to get 24 over 5. All right. So that's the point where we put the tick marks here. All right. We have to put the tick mark at 0. And then also 24 over 5. All right. Then we look at the sign of f prime. All right. So we have f prime. So f double prime, sorry. All right, so we try any number less than negative 0, so it's going to be -1. All right, so this is an easy one to probably look at here. All right, so the denominator is always positive, so because of the even power, so we just have to look at the top. All right, so -10 minus 48, so it's going to be negative, so it's going to be negative there. Between 0 and 24 over 5, so we can try x equals 1. So sample number x equals 1. All right, so here you have 10 minus 48. It's still negative. So it's concave down there. All right, after 24 over 5, so we can try x equals, what's 24 over 5? So x equals 5 would work, right? So 50 minus 48, now it's going to be positive. Right? So the original function f is going to be concave down here, and concave up there. Right? So it's concave up only after 24 over 5. So let's put that. Right, concave up is 24 over 5 to positive infinity. Right? So we have that. And before that, so it's going to be negative infinity to 0. And we're going to have to skip 0 because function is not defined there. And then 0 to 24 over 5. Right? And the inflection point is going to happen at 24 over 5. That's the only place it changes concavity. So I'm going to do that. And then we have to plug it in here, right? All right, so we need to compute f of 24 over 5. So this is equal to 1 plus 5 times reciprocal of x. So it's a 25 over 24. And minus 8 times reciprocal of x squared. So it's going to be 5 squared is 25, and then 24 times 24. Right? So we can cancel 8 and 24. So here 8 and 24, you get 3. And so we have common denominator would be 3 times 24. So it's going to be 72. So 72, right? So 1 is same thing as 72 over 72, right? 25 over 24 is, we have to multiply top and bottom by 3, so it's going to be 75. And then minus 25, right? So this is going to be 50 plus 72 is 122 divided by 72, right? So these are divisible by 2, so divide by 2, that's 61. And then this is going to be divisible by 2, so it's going to be 36. Right? Is 61 divisible by anything? I don't think so. So 61 over 36. Right? So we have 61 over 36. Right, so let's check the answer here. Oh, actually, I put a wrong number there. It's 61 over 36. 61 over 36. All right, let's check the answer. All right, I came back and looks like we got the inflection point correctly. All right. Let's move on to part E. Use the information to sketch the graph of f. All right, so first we want to have a vertical asymptote at 0. All right, this one has it, this one has it. Actually, everyone has it. Yeah, so it's not going to be good. It doesn't tell us anything. Horizontal asymptote is 1, y equals 1. All right, here, not y equals 1, so number 2, no, so we can eliminate that. So it's between third one and the fourth one. All right, so we got that. All right, then increasing, decreasing behavior. All right, so the find interval of increase. So in the beginning here, it's actually decreasing. All right, this picture in the beginning is decreasing. Here in the beginning, increasing. So this got to be the correct picture. All right, let's check the answer. All right, it came back and looks like we got the correct picture. All right, that's it. I hope that this was clear.